Hey everyone, it's me. I am here. Alright, I'm maybe not totally here. We're working from home these coming weeks, so you'll have to do with picture me. 1/10 the realism, but 10 times the smugness. Now, what if I told you that you can actually make changes to your game after it has already launched, without pushing an update and without even opening Unity? So, when creating a video game, most people think of all the things you need to do before publishing the game. However, a lot of game development these days is actually about making sure your game is fun to play after it has been released. For example, if you release your game and immediately get reviews saying that the second boss is too hard, this of course needs to be fixed. Or if your game has been out a little while, you can keep it interesting by introducing new features or seasonal events. And sometimes you want to introduce a feature to only a part of your audience. For example, to see how they react before rolling it out to everyone else. Luckily, all of this has just gotten incredibly easy to do with Remote Config. This is a new version of Remote Settings, a feature that's been around for a while, but for some reason almost no one knows about. What Remote Config allows us to do is not only make changes to our game, but to do it remotely and without having to push an update. In fact, we can adjust game variables and trigger game events just using a browser, and the changes can be pushed to the players while they're playing the game. Pretty cool. But first, this video is sponsored by Jason Wyman. Jason Wyman is an industry professional, and he just created a new amazing course on game architecture. The course teaches you exactly how to structure your game and code in a professional manner to avoid all the headaches you might run into while creating a bigger game. It will teach you everything from writing testable code to project structure management, advanced state machine development, and the list goes on. The most awesome part is you'll learn everything through building your own unique RPG, where you get to build quest systems, learn about inventory management and interfaces, and even branching dialogue systems. What's very unique about this course is that new content is constantly being added, and you get access to weekly live Q&A sessions with Jason himself, alongside with email support and a Discord channel where you can chat with your fellow students. So no more getting stuck on problems you just can't solve. So sign up now and get a free t-shirt included from Line of Code using the link in the description. Alright, let's get into it. So as you can see, I'm here in Unity, and I've gone ahead and set up this incredibly simple example scene. In fact, all I have in here is pretty much just a light, a main camera, as well as this cube. And let's try controlling the color of this cube using a remote config. So to do that, we first need to make sure that we install remote config through the package manager. So we'll go Window, open up the package manager. Here we'll search for remote config, select it, and make sure to hit install. As you can see, I've gone ahead and done this already. Once it's installed, we can open up the remote config window. Let's go Window and open up remote config. I'm just going to take mine here and dog it to the bottom of my screen. There we go. And your window might not look exactly like this just yet. The reason for this is that in order to use remote config, we need to link our project to a Unity Cloud Project ID. To do that, we'll go Window, go under General, and open up Services. And if you aren't already, you will be prompted to log in here with your Unity ID. You're going to select or create an organization that you want this game to be under. Don't worry, this can always be changed later. And once you finish doing this, you should get to this screen right here. This allows us to use all kinds of Unity services like ads and analytics. And it also allows us to start using remote config. If you want to make changes, you can always go to the Settings tab here, rename your project, change the organization, or even unlink the project entirely. And once this is done, our remote config window should be ready to use. This window is going to show all of our settings or configs on the right and all of our rules on the left. Now this window is connected to the cloud, so let's first make sure we're completely synced. We do this by clicking Pull to get all changes from the cloud. And right away you can see that we don't have any settings or rules yet, but we do have two different environments to choose from: Release and Development. And each environment stores their own settings. The release environment is meant for finished builds, while development is used while testing in the editor. We are currently testing in the editor, so we'll choose development for now. And you can also use the development environment for test builds by simply going to the build settings and checking the development build checkbox before exporting. Alright, now we are finally set up and ready to add some settings. So let's go down here and hit Add Setting. Let's rename it to something like Cube is blue. And as the name suggests, this variable is going to control whether or not our cube should turn blue. I'm also going to select a type. Here we have different default variables like string, bool, floats, and ints. I'm just going to choose bool, which allows us to set a value of either true or false. By default, let's just set this to false, and we can now push these changes to the cloud by hitting the push button. And because this is connected to the cloud, we can already open this in a browser and make changes there as well. So if we hit view in dashboard here, it's going to open up this browser window where we can log in with our Unity ID. And right away we get taken to this dashboard here where we can view our different environments. As you can see, we have release and development. We can view the different configs. In fact, we can see the one that we just created here. It's called CubisBlue. It's a Boolean and it's set to false. And we can also go in and view rules and reports. And if we want to make changes, it's as simple as setting the value here and hitting save. But before we do that, how do we actually load this setting into our game? Well, let's create a quick script on our cube that gets the setting from the cloud and then sets the color of the cube depending on the value. So I'm going to hit add component here. I'm just going to call it cube. Let's hit create and add and double click it to open it in Visual Studio. And whenever we're working with remote config, we want to make sure that we import the right namespace. We're going to be using unity.remoteconfig. Another thing that we have to do is we have to create two struct variables. I'm going to create a public struct called user attributes, and the syntax for an empty struct is like this. And I'm going to create another public struct called app attributes. And by default, these two are not going to do anything. But if we later want to add custom attributes like a player name, age, skill level, or so on, we can do that here. And then change things only for people with certain attributes. But for now, we'll just leave these completely empty and have this value be the same for all our players. Next up, let's create a public bool for our isBlue value and set it to false by default. Then we can go ahead and get rid of the void start method. Let's instead add in a void awake. And remember, the awake method is the same as start, but it's called even before start is. And so it's great for setup that needs to happen as early as possible. In here, we can go ahead and use config manager in order to call a function called fetch configs. And basically what this does is that it goes to the server and pulls down all of the settings that are there. And the syntax for this is a bit weird. It's a generic method, so we have to put in our user attributes first here. We can then put in our app attributes. These are references to the two structs that we put up here. And these are just the types. We also need to pass in a new user attributes as well as a new app attributes. So if this syntax is completely new to you and a bit confusing, I totally understand. For now, you can just write after me. What we're doing here is essentially just saying that we don't want to input any kind of custom attributes. We just want to use default settings. And these are going to go ahead and get all of our variables. But we also need to create a function that is going to take these variables once we get them and do something with them. So let's go ahead and create some kind of function here. Let's do void. And let's just call it something like setColor. This is going to take in a config response, and a config response is basically just an object that has some information about how the process went. As you can see, if we go under this response object here, we can know things about the status, as well as the request origin, which tells us if the data that we got came from the cloud or we just used something that was local to the computer in case our connection didn't come through. You can of course go ahead and use this if you want to change what happens depending on that response. But in our case, we can just go ahead and omit that. Instead, what we want to do is go ahead and set our isBlue variable equal to config manager.appconfig.getBool. And the boolean that we want to get is called CubeIsBlue. And that is simply going to go ahead and load the value of our config into our local variable. Awesome. Now, the only thing that we need to do is make sure that this setColor function is called whenever fetch configs goes through. To do that, before we fetch the configs, we can go ahead and subscribe it. So in our config manager, we can do .fetchCompleted, and this is a callback that is going to be called whenever our fetch is complete. So here we can go ahead and plus equals, so we'll add onto this callback the setColor method. In other words, we're telling our config manager that once it's done, we should call the setColor function, and then we start fetching. Once that completes, it's going to go down here to our setColor. We're going to get the right value and set our isBlue variable equal to that variable. So that's what's happening here. Pretty cool. And that means that we can now do things depending on this variable. So let's go ahead and add two materials up here. We'll just create a public material. Let's call this the blue material. Let's create another one called the red material. And let's also create a reference to our renderer. Let's just call it rend. And then down here we can say that, well, if our isBlue value is true, well, then we can set rend.material, so the material of our cube, to our blue material. And if it's not blue, well, then we can set the material to our red material. And with that, if we save and go into Unity, and under our cube, we can assign a few materials. I've already gone ahead and created a blue material here, as well as a red material that we can use. And we'll also assign the renderer, so that's just the renderer of our cube here. If we now hit play, we can see that our isBlue variable is false, and indeed our cube immediately turns red. However, if we go ahead and change the value of our setting here to true and push that, well, then we should see that if we play, our isBlue variable turns true and the cube indeed turns blue. So that's really cool, but even cooler is the fact that we can actually fetch settings while the game is playing. So if we go back into our script here, we could go into the update method and add a little bit of code that is going to fetch some settings every time we press our mouse button. So to check if our mouse button is pressed, we go if input.get mouse button down. And I'm just going to check for the left mouse button. And if I press that, we can go ahead and call config manager.fetch configs. And we're going to do that using all the same settings as up here. So we can simply copy this entire line and paste it here. And notice how I'm not resubscribing the setColor method. We only need to do this once, and then the config manager is going to remember that we still want to call the setColor function whenever we fetch some new configs. In fact, it's good practice to make sure that we remove this function from the callback whenever we're not using this script anymore. So I'm just going to go ahead and add a quick function here called onDestroy, which is a method that is called whenever this object gets destroyed. And then here we can go config manager dot fetch completed minus equals the setColor method. This way we make sure that we don't end in a situation where our config manager tries to call a function on an object that is no longer there, just in case we remove our cube or something else happens. So with that, let's now save this script, go into Unity, and instead of just playing the game, let's actually try and build it to really see this in action. So let's go File, Build Settings, make sure that Development Build is checked, and we can then hit Build. I'm just going to create a quick folder for this called Builds. Select that, and Unity is going to build the game. There we go, we now have the build right here. I'm going to go ahead and launch it. And as we can see, immediately our cube turns blue, because the isBlue variable is currently set to true. And the same thing should happen if we play the game inside of our editor. However, if I now change this variable, we could either do that inside of here, or we could go to the dashboard in our browser here and change the value from true to false. Let's hit save and confirm. And remember, you can access this from any computer without Unity even being installed. I have Unity running right now, but you really don't have to. If we then go back into our editor and click, we can see the cube immediately turns red. And the same thing should happen if we click inside of our build. Really, really cool. So we've now changed settings on our build game just using a few clicks in the browser. Now, this is of course a really simple example. Let's try to apply this to a real game. So let's hit pull here in the editor just to make sure that we're up to date. And now, as you can see, I've gone ahead and loaded in a quick top-down shooter that we made for our video on 3D scanning. As you can see, the objective for this game is to kill enemies in order to stay alive as long as possible. But let's say that I'm not quite sure if the difficulty of the game is right. Well, in that case, let's go ahead and make the enemy spawn rate and the enemy health changeable using remote config. So I'm going to go ahead and do this in the browser. Let's open up our dashboard here, and let's start off by adding a new key. For the key name here, I'm going to type enemy spawn rate. I'm going to set the type here to a float, and I'm going to enter a value of something like 0.3. Let's hit add in order to add that key. Let's go ahead and add another one. This one is going to be the enemy health. Of the type here, I'm going to set it to integer for whole values, and I'm going to set the health to something like 40. Let's again hit add. And now all we need to do is fetch these variables through script. So let's save this here and hit confirm. Let's go into Unity, and this process is going to be the exact same as with our cube example. In fact, I've gone ahead and made an example of how you could do this. So I have this spawner object here with an enemy spawner script. This script, as you can see, has a few variables. Two of them are the enemy spawn rate and the enemy health. If we go ahead and open up the script As you can see, the two variables are right here, and we use them different times in our script, such as when spawning here, we're setting the time to spawn to be equal to the current time plus 1 divided by our spawn rate. And later when we are spawning our enemies, we're accessing that enemy and setting the health equal to our enemy health. So we're using these variables throughout our script, but the code responsible for updating it is actually really simple. We're using the unity.remote.config namespace like we did with our cube. We're adding in 2 empty structs, one for user attributes and one for app attributes. We have an awake method where we have 2 lines of code, one that fetches the configs, and before that we have one that subscribes a function to our callback. In our cube example, this was called setColor. Here I've just called it apply remote settings, and the function, as you can see, is right here. It has the same structure, it's a void, you can name it anything you want, and it takes in a config response. Then in here, we set the enemy spawn rate equal to config-manager.appconfig.getFloat, because this is a type float and not bool, and then we pass in the name. We do the same thing with the enemy health, except this time we use getInteger, because this is an integer. And then again, pass in the name of the variable. And that is all we're doing. Oh yeah, and then of course at the very bottom here, we have the onDestroy function that simply removes the callback. Again, just like we showed. So the script in itself is actually really simple, and the simplest part almost is actually updating these settings. And I'm updating these settings inside of awake, which means that they should update every time the player dies, because that just reloads the level and so awake gets called again. And if we play this, we should see that immediately our enemy spawn rate gets set to 0.3 and our enemy health gets set to 40. And indeed, our enemies are spawning fairly slowly and they die with just a single shot. So far this game is not very challenging. Let's say we've built this distributed to players and that's kind of the feedback we're getting. People are saying that this game is way too easy. Well then, we could simply go ahead and change this. So I'm a player here that's currently playing the game. If we then go into our dashboard here, we go in and we change the value of, say, our enemy health here. So we'll modify that to something like 100. And we'll also set the enemy spawn rate to something more like 0.7. Well, then we can go ahead and simply save these changes, hit confirm. And then once the player dies inside of Unity here, the scene reloads. And so all of our values are loaded up again. And if we now have a look at the spawner, the variables have indeed changed and we can see the result. The enemies are now much harder to fight and they spawn much faster. So cool. Now the final thing that we can do with this is add rules. The rules allow us to target only specific parts of our audience. For example, if we go to our dashboard here, we can go ahead and add a new setting. Let's call this something like is Halloween. And we'll make it a boolean and set it to false by default. Let's add that and save that change. Now, we don't want it to be Halloween all the time. It would be awesome if we could schedule this variable to change. And also, not all cultures celebrate Halloween. So maybe we could limit this to only certain countries. Well, in that case, let's go under rules here and let's go ahead and create a new rule. We'll name this something like Halloween and hit create. And in here you can see that we get a bunch of settings. First off, we have the name, we just set that. We also have a priority in case you have multiple rules trying to change the same settings. The lower this is, the higher the priority. I'm just going to leave this at 1000. We then have the type. This is currently set to segmentation, which means that we're going to set the same value each time. You can also set this to variant, which is going to allow us to pick from a list of variant values in case you want to mix things up. For now, let's just leave this at segmentation. We can then schedule this rule to occur between 2 dates. This is perfect for something like Halloween. But just for testing purposes, I'm going to set this from yesterday to tomorrow. And of course, you can put in a time as well. This way you don't have to be online to make sure that things happen in your game. And under audience criteria is where things really get interesting. Here we can choose, for example, a condition. A condition allows us to choose to target players with certain attributes like we talked about. As you can see in the documentation, there's a list of default attributes that you can choose, like country, language, and platform. We'll of course have a link to this in the description. If, for example, we only wanted to target people in the US, we would write unity.country is equal to US. But I'm just going to leave this out. What I just wrote there is called a JEXL expression, and we'll have a link to where you can learn more about the syntax if, for example, you want to apply multiple different conditions. Also, these are just the default ones we talked about earlier. Remember, you can add your own custom attributes and use these to create conditions as well. Again, we'll have links to where you can learn all of this stuff in the description. Moving on, the rollout percentage is the percentage of the user base that this rule is going to apply to. This way we can easily test certain configs for only a small percentage of our audience at a time. I'm just going to leave this at 100 for now. And finally, we get to adjust what keys this rule is going to affect. So in other ways, we can go in here and add the settings that we want this rule to change. In our case, we wanted to change is Halloween and set that to true. But you could easily go in and crank up the difficulty during Halloween or set a cube to another color. So let's save that now. Go back to parameters and everything looks good. And now inside of Unity, we can of course go ahead and use our is Halloween config like any other setting. I've added this seasonal events object right here that has a Halloween script. As you can see, it has a few variables. These are just references to objects that we turn on and off depending on whether or not it's Halloween. So if it's Halloween, I turn on the Halloween lights and disable the normal lights. And I also turn on the pumpkin graphics for our player instead of the default graphics. It's really not that complicated, but it works fairly well. And if we go ahead and open up the script, it's just as simple as all the other ones. We have the namespace, we have the structs, we have a variable called is Halloween. Then in the awake, we subscribe a function, we call fetch configs. Once that is done, we get the boolean value, set our is Halloween variable depending on what we get. And then if it's true, we set up for Halloween and enable all the Halloween stuff. And if it's not, well then we set up for default and enable all of the default stuff. And we can see this working. If I go in here and hit play now, as you can see, nothing happens. And that's because we haven't enabled the rule. So if I go into my dashboard now and click enable on the rule, well, we're currently inside of the start and end date. So if we go into Unity, voila, immediately our game loads all of the Halloween stuff and we have a successful seasonal event. And it's really, really fun to play around with giving this kind of stuff to your players to keep your game new and refreshed. Awesome. Of course, something like this that changes all the graphics of your game, I would recommend doing during some kind of loading screen. Otherwise, you might get some weird behavior while you're waiting for the values to fetch from the server, like we see here. It just takes a little bit of time before everything actually loads. But that's completely up to you. You can fix that even just with a simple fade to black script. Woohoo! That's pretty much it for this video. If you enjoyed it, make sure to subscribe and ring that notification bell so you don't miss the next one. Also, don't forget to check out Jason's course on game architecture. Learn how to probably make big games by simply clicking the link in the description and get a free t-shirt included. On that, thanks for watching and I will see you in the next video. Thanks to all of the awesome Patreon supporters who donated in March, and a special thanks to Ville Vertanen, Lost to Violence Love Forever, Faisal Marify, Leo Lisette, Nobby Ninja, Jim Schubert Jazz, Daniel Dusanik, Dante Sam, Jacob Sanford, Marc-Antoine Girard, Naoki Wasaki, Gregory Pierce, Michael Korobov, The Mighty Zeus, Owen Cooper, Elson the Fierce, Erasmus, Yijit Kaya, Ismail Lukusa and Sirius Wolf. You guys rock!